Hello, today we will discuss about series AC circuit. Okay, so AC series circuits means that you have a source, uh, usually a resistor, a inductor, and a capacitor. Okay, they can be arranged any other way, so doesn't matter. So this one is R, this one is L, this one is C. So R usually, for example, is 10 ohm. For L, usually in Henry. So for example is 1 maybe 2 millihenry, and for capacitor is usually in farad. So 330 microfarad. So the source are usually in, for example is 200 sine 300 t plus 0. Okay, this is the source. Okay, so this all of this is in time domain. So when the question asks you to solve the AC circuit, first you have to change the time domain to frequency domain. Okay, for frequency domain, this one, of course, the source, you have to change to phasor domain, which is 200 divided by square root 2 degree 0. So resistor, inductor, and capacitor cost the same, but for resistor is 10 ohm. For inductor is, if you look here, this is in Henry. So when you want to solve the AC circuit, you need to change everything in ohm. This one needs to be in ohm. So how to do this? For inductor, X or ZL, which means the impedance of an inductor is 2 pi R 2 pi L 2 pi F L O W L, and don't forget the J. So if they give the frequency here, the frequency you can use, usually F is equal to 15, but if they give like this, you cannot use this, you just take this. This one is W. Okay, W. So J 300, use this one, 300. L is 2 milli, 0.002, so equals to, so if you use your calculator, goes to complex. So J 300 multiplied by 0.002 I, so you get 0.6 J 0.6. This one is in ohm, so 0.6. Now you have changed from time domain to frequency domain. So for capacitor, you have to change. So ZC, impedance of capacitor, is negative J over WC, or negative J over 2 pi FC. Which one? Depend on the question, you can use either this one or this one. If they give W, you use W. If they give frequency, you use frequency. So this one is negative J divided by 300. So ZC is equal to negative J divided by 300 multiplied by 30 multiplied by 10 negative 6. So the answer is, so 1 divided by 300 divided by 30 negative 6. So you get 111.11 ohm. So impedance is always in ohm. So 111.11 ohm. Now you already convert the time domain to frequency domain. This is a standard. So the next question I usually ask you to get the total impedance. Zt equals to, for series you have to just plus everything. So R plus ZL plus ZC. So R is 10 plus 0.6 plus 1.11. So and don't forget this one is negative J, right? And below here is J. So J negative J. Don't forget that. So 10 minus 0.6 J minus 111.11 J. So you get negative J 110.51. This one is the total impedance. So how to get the current? Because this is a series circuit, so you just I total equals to, this is the V source, Vs divided by Zt. So Vs is 200 square root 2. Okay, angle 0 doesn't need to write, and then divide by 10 minus J 110 and 0 5 1. So IT equals to so 220 200 divided by square root 2 divided by, don't forget the bracket, okay, 10 minus 110.51 shift, no need to shift, okay. So you get this and this, but for current you need to use the rectangular form, the polar form, which is this one. So the current will be 127 point, sorry, 1.27, the angle of 4.83 ampere. Okay, so this one is in ohm. Okay, this one is in ampere. So now after you get the current, total current, the next question should be, usually you have to get the, maybe for, usually for series circuit you have to find the voltage for depending on the component. Okay, so you have to find the voltage. One way, the first method is use Ohm's law. So this is the easier one. So if the question asks find the current, find the voltage at L, so you just VL equals to ZL multiplied by I total, because this is a series circuit, so the current will be the same for each one. So ZL is J 0.6. okay, if you look here, this is 0.6, and don't forget this one J, this one negative J. Okay, so J 0.6, then multiply by, okay, from here is 1.27 4.83. So you get the voltage, so 0.6 multiplied by 1.27, 84.83. So for voltage also you have to use the polar form. So for polar form, so the voltage here V at L is 0.762, and the angle, don't forget the angle, is 107.486 degree. And the second method is use voltage division. So because for example, if you want to find VC, for example, okay, so VC is equals to, so you have to look here. So this one, take this one, is actually ZC divided by Z total multiplied by Vs. Okay, because this is in series, so the voltage total here is here, and you have to use division. So if you want to find the voltage here, you have to use this formula. Okay, so we see ZC is negative J111.11, so divide by Z total. Okay, you can check here, is 10 minus J110.51, and the Vs is 200 divided by square root 2. So just key in into your calculator. Give 111.11 divided by 10 minus 110.51, okay, divided by 200 divided by square root of 2. So don't forget to change to polar form. So the voltage here is 141.61. Okay, the angle is negative 95.17. Okay, you get this and get the answer. So another popular question for this is a polar phasor diagram. Okay, so usually they ask you, for example, the phasor diagram for V, for example, Vs and IT. So you just draw the Vs and IT, don't include this. You just answer what they want. So Vs is 200 0 degree, right? So 0 Vs 0 degree, and Is is, if you look here, or I total is goes this way. Make it smaller because this is 1.2, voltage is 200, so I total, and don't forget to put the degree 84.83 degree. So if they ask all the current, so you have to draw all the current. Okay, all phasor diagram for IT, IR, IC, I. For example, the other question that popular is, okay, Vs, VR, VL, and C. So draw a phasor diagram for Vs, Vr, Vl, Vc. If he asks like this, you have to draw the Vs. So Vr is around here, okay, which usually in phase, okay, we don't calculate it, but usually in phase with the I total, IR, okay, so 84.84. So VL, so you look at VL is 174. So this one should be smaller, okay, because the water is smaller. This one also smaller. So VL, this one you have to put 174 point, this one 86. So this one is usually 90 degree from the VR. So VC is 90 degree but at a lower side. So this one, so there is a correction for VC, okay. Be careful when you use your calculator, okay. So this one should be on here, negative 5.17. This one should be bigger, VC, okay. So correct this, okay. So Vs at 0 degree, this one is VR, okay. Make it shorter because the amplitude usually smaller. If you calculate this, it will be small, okay. Then this one is 84 point something, right? 84 degree, so small. VL, this one is 174 or 175 degree. And lastly, this one is larger, VC, negative 5.175 degree. So you already draw the phasor for Vs, Vr, Vc, Vl. And lastly, you have to calculate the power. So what is total power provided by our supply? So this one you just P equals to, so depend what total power. So they will ask either reactive, real reactive or apparent power. So this one, so usually just U is equal to V S I total, okay. So this one you get. So depend on the question. If they ask real power, this one is complex power, okay. So Vs is 200 square root 2 degree, okay. And IT is where is it, 1.27, okay, 1.27 degree. Don't forget this is conjugate, and conjugate, okay, if you look here, positive, it become negative 84.83. So just use your calculator, you get the apparent power. So the apparent power is you use the rectangular form, so the answer will be P plus JQ. So this is the real power. This one become the apparent power, okay. or the answer can be S. So your answer, okay, this one is complex power, this one is apparent power, this one is reactive power. REACTIVE, reactive power. This one is apparent power. Okay, and the angle. So you can, for complex power, you can show both answer because it contains real power, reactive power, and apparent power. And this one is the angle. You can use as cos theta. You get the power factor. So this is the common question for series AC circuit.